Today's lesson is going to be pretty quick. We're going to graph two lines, making a table and graphing the ordered pairs. I do want to point out that the reason that we know that these equations are linear is because they follow those rules that we talked about, no exponents and only two letters, so pretty normal. So I know that whenever I graph this, it should look like a line. You can use that to see if you're doing your math correctly. So because y is all by itself, I'm going to go ahead and plug 0. Because y is all by itself, I'm going to go ahead and plug 0 in for x. And I'm just going to do this in my head. 1/2 times 0 is 0. And then subtract 3, you're going to get -3. Now I do want to point out you can pick any x values that you want. You don't have to use mine. I just usually pick numbers that are pretty close to the origin. They're usually a little easier to graph. And I also picked 2 and -2 because I knew I'd be multiplying by half, and I don't really feel like graphing fractions. So if you pick multiples of 2, you won't have a fraction answer to graph. So 1/2 of 2 is 1. 1 minus 3 is -2. So I'll do that one next. And then 1/2 times -2 is -1. Minus 3 is -4. So we're going to plot these and hope that they make a line. Hope we did our math correctly. So there's the first point. There's the second point. And we'll go off our graph a little bit. Not a lot, but that's okay. All right, so there's our line. Whoops. And as you can see, it does make a line, so chances are we did it right. In our next example, it's not going to be as convenient just because y isn't all by itself. So we are going to have to do some math after we substitute random values for x. So I just picked 0, 1, and 2. Again, just trying to keep my numbers small and kind of close to the origin. So if I do 2 times 0, that just kind of goes away. And I would divide both sides by -4. And just to kind of save on time, 6 divided by -4 is going to be -1.5. You're going to want decimals or mixed numbers because it's hard to graph improper fractions in ordered pairs. So decimals are usually what I go with. 2 times 1 is 2, which we're going to subtract from the 6, leaving me with -4y equals 4. So I'm going to get -1 for y. 2 times 2 is 4. If you take that from the 6, you're going to get 2, and you have -4y over here. And if you do 2 divided by -4, you get -1/2. So let's graph these and see if they make a line. So we have 0. We're going to go down 1.5 spaces. Then 1, -1. Then we're going to go over 2 and down just a half a space. And there's our line, so it looks pretty good. There is a second method to graphing linear equations, and this sometimes is a little bit more convenient, and it's going to be by finding the intercepts, the x-intercept and the y-intercept. So if you remember from our previous videos, you need to make an x-intercept column and a y-intercept column. If we're solving for x, that means we need an x in the problem. That means 0 has to go in for y. And the y-intercept, of course, was reversed. So we're going to put 0 in for x and leave y in the problem. And then if we go through and we solve this, we will be getting x equals 4 and y equals -2. And because these are intercepts, you are supposed to rewrite them as ordered pairs. So you just want to make sure you put 0 in the correct spot. And then we just plot those ordered pairs. So right here is 4, 0, and then 0, -2. And that's our line. So usually when I see a line that's written kind of in this form, I usually just graph the intercepts really quick. Sometimes you can do them completely mentally, and it's just a little bit quicker than making this table and solving all these equations. So we'll try it one more time. X-intercept, y-intercept. X-intercept needs an x, and y-intercept needs a y. So x equals -2. y equals -6 means we have -2, 0, and 0, -6. And if we are to graph that, y-intercept's about here, x-intercept's about here, and there's our line.